In this video, let us solve few problems related to application of multiple and submultiple angles of trigonometric functions. So in this first question, the information given to us is sin x is equal to 3 by 5 and x is greater than 0 and less than pi by 2. That means this is in the first quadrant. So using this information, we have to find the value of sin 2x, cos 2x, tan 2x and sin 4x. Now, before we start solving this question, let's first find out what is the value of cos x so that we can apply sin and cos depending on what trigonometric function we are trying to calculate. Now, the basic trigonometric identity, we are going to use it now. We have cos square x plus sin square x is equal to 1. So cos square x is 1 minus sin square x. Now cos x is positive value of the square root of 1 minus sin square x. The reason we are using the positive value is the information given to us is that x is in the first quadrant, and in the first quadrant all the trigonometric functions are positive, including cos. So now if we apply the value, we would get cos x is equal to square root of 1 minus sin square x is 9 by 25. So this would be square root of 25 minus 9, which is 16 by 25. So cos x is 4 by 5. Now we know the value of cos x. So tan x is sin x by cos x. So we would get tan x is 3 by 4. Now we have the value of cos x, tan x and sin x. Let's apply this to find the value of the cos 2x, sin 2x, tan 2x and sin 4x. So the first one, sin 2x, we know the formula as 2 sin x times cos x. So this will be 2 times sin x is 3 by 5 and cos x is 4 by 5. So this will be 2 times 3 is 6, 6 times 4 24 by 25. Now let's approach the next one. So the next one is cos 2x. Now the formula of cos 2x, we know that it is 1 minus 2 sin square x. So if we apply that, it is 1 minus 2 times sin square x is, sin x is 3 by 5. So sin square x is 9 by 25. So we will get 25 minus 18 by 25, which is 7 by 25. So that is the value of cos 2x. Now tan 2x can be easily found written as sin 2x by cos 2x, but just for the sake of learning the application of formula, let us apply tan 2x is equal to 2 tan x by 1 minus tan square x. So in this case we will have 2 times tan x, we found the value as 3 by 4. So this will be 2 times 3 by 4 divided by 1 minus tan square x is 9 by 16. So we can reduce this fraction. So this will be 3 by 2, 7 by 16. So we can reduce this to tan 2x is nothing but 24 by 7. So this is the application of tan 2x formula. Now just to verify, tan 2x is sin 2x by cos 2x. Now we know sin 2x is 24 by 25 and this divided by cos 2x is 7 by 25. We can cancel the 25, so it is 24 by 7. So we could easily apply it sin 2x by cos 2x, but we wanted to learn the application of these formula we learned in the previous video. That's why we took this approach. Now the last trigonometric function we have to solve is sin of 4x. So sine of 4x can be written as sine of 2 times 2x. So this will be 2 sine 2x times cos 2x. Now we know that this is 2 times. We found the value of sine 2x, and that is equal to 24 by 25. And cos 2x is 7 by 25. So if you multiply all this together, the denominator would be 625, and this would be 48 times 7, and 48 times 7 would be 336. So that is the value of sine 4x. So this is how we can apply the multiple angle formula. Let us solve more problems now. Now in the next question, the information given to us is tan alpha is 1 by 7, sine beta is 1 by square root of 10. So using this information, we have to prove that alpha plus 2 beta is pi by 4. So to solve this, let us apply the information we have learned, that tan of pi by 4 is equal to 1. So this is the value of tan at angle pi by 4 or 45 degrees. So that means we have to prove that alpha plus 2 beta will be equal to pi by 4. So now let's try to solve this. So what we can do here is, using this information, first let's find out cos of beta. So cos beta would be square root of 1 minus sine square beta in the positive value, because beta is in the first quadrant. So if we apply this, we would get square root of 1 minus 1 by 10. So this would be square root of 9 by 10, which is 3 by square root of 10. Okay, now we know the value of cos beta. Now what would be the value of tan beta in that case? So tan beta would be sine beta, which is 1 by square root of 10, divided by cos beta, which is 3 by square root of 10. So tan beta would be 1 by 3. Now we know the value of tan alpha, which is given in the question, and tan beta. So what we can do is, let's apply the formula of tan of a plus b. So tan of a plus b is tan a plus tan b divided by 1 minus tan a tan b. So in this case, we are trying to prove a plus b is nothing but alpha plus 2 beta. So this would be tan alpha plus tan 2 beta, whole thing divided by 1 minus tan alpha tan 2 beta. Now when we apply, we require the value of tan 2 beta. How do we get the value of tan 2 beta? We know that tan beta is 1 by 3. So tan 2 beta is 2 tan beta by 1 minus tan square beta, correct? Which is nothing but 2 tan x by 1 minus tan square x. So 2 times 1 by 3 divided by 1 minus 1 by 9. So this will be 2 by 3 divided by 8 by 9. So this will be 6 by 8, which is 3 by 4. So tan 2 beta is 3 by 4. Now we know the value of tan alpha and tan 2 beta. So tan alpha is given in the question, which is 1 by 7. So let's start applying it to this formula here. So tan of alpha plus 2 beta is equal to 1 by 7 plus 3 by 4 divided by 1 minus 1 by 7 multiplied by 3 by 4. So this will be, common denominator is 28 divided by 4 plus 21, whole thing divided by 28 minus 3, 25 by 28. So we can cancel this out. This will be 25 by 25, which is equal to 1. So tan of alpha plus 2 beta is equal to 1. That means alpha plus 2 beta is equal to pi by 4. So this is how we can prove that alpha plus beta is pi by 4 by application of two important concepts here. One is this formula, which is tan of a plus b. We have solved a lot of questions related to this in other playlist. Please refer that. And another application we did is application of tan 2 beta, which is nothing but tan 2x or tan 2a, however you want to recall it. So now let's go to the next question. Now let us try to solve these 5 problems. Here we are going to apply the multiple angle formulas of trigonometric functions. So please note down these questions, give it a try yourself, and you can also watch the video to understand how to solve these questions. But give it a try yourself so that you get a hang of how to apply these formulas. Now let's start the first one. Let's try the first one now. So here we have to prove that sin 2x divided by 1 plus cos 2x, this will be equal to tan x. Now let's apply the formula of sin 2x. Sin 2x is 2 sin x cos x, this divided by 1 plus cos 2x is, now we have to arrive at tan x. That means we have to have a denominator of cos. So what we can do is cos 2x can be written as 2 cos square x minus 1. Now the ones will be subtracted and we will have 2 sin x cos x divided by 2 cos square x. We can cancel the 2 and we can cancel one of the cosines, and this will be equal to tan x. Now let's try the second one. Here we have to prove that sin 2x divided by 1 minus cos 2x is equal to cotangent of x. So sin 2x is 2 sin x cos x divided by 1 minus, now here we need cotangent of x as the proof. So we will have a larger degree of sign in the denominator. So we can write this as 1 minus 2 sine square x. So the ones will get cancelled. So this will be 2 sine x cos x divided by 2 sine square x, because the negative of negative is positive. So we can cancel the 2 here and 1 degree of sine is cancelled. So this will be equal to cotangent of x. Now let's try the third one. Now in the third one we have to prove that 1 plus sin 2x plus cos 2x, the whole thing divided by 1 plus sin 2x minus cos 2x, this will be equal to cotangent of x. Now because we need the proof to be cotangent of x or cot x, we know that the denominator should have a sign in it. So to have a higher degree of sign, what we are going to do is, in the denominator for cos 2x we will apply it as 1 minus 2 sine square x, but in the numerator for cos 2x we will apply it as 2 cos square x minus 1. So let's start applying the formula. So 1 plus 2 sin x will be, sin 2x is 2 sin x cos x plus 2 cos square x minus 1. This whole thing divided by 1 plus 2 sin x cos x minus of 1 minus 2 sine square x. Now the ones will get cancelled here. The ones will get cancelled in the denominator too. So we would have 2 cos x as common in the numerator, and this will be sin x plus cos x. And in the denominator we can have 2 sin x as common again, and this will be again sin x plus cos x, because the negative of negative would change to positive. Now we can cancel this out and this will be cotangent of x. Now let's try the fourth one. In the fourth one we have to prove that 1 plus sin x minus cos x, the whole thing divided by 1 plus sin x plus cos x. This will be equal to tangent of x by 2. So we know that from the question. Now how do we change it to x by 2? So if you notice here, this problem is very similar to question number 3. Only thing is that sine 2x has been expressed as sin x. That means this can be changed to submultiple angles, which is 1 plus sin x is nothing but 2 sin x by 2 cos of x by 2 minus, now we need tangent, so we'll have a higher degree of sine in the numerator. So this is 1 minus sine square x by 2. This whole thing divided by 1 plus 2 sine x by 2 cos x by 2 plus 2 cos square x by 2 minus 1. Now we can cancel out 1 in the numerator as well as denominator, and we will get 2 sine x by 2 as a common factor, and this will be cos x by 2 minus plus sine x by 2. This whole thing divided by, again we can get 2 cos x by 2 as a common factor, and we would get sine x by 2 plus cos x by 2 as the value. Now we can cancel out cos x by 2 plus sine x by 2. We can cancel out 2's. So this will be tan of x by 2. Now in the fifth question, we have to prove that cos 2x divided by 1 plus sine 2x is equal to tan of pi by 4 minus x. So this is a unique question. Here we have to apply all the concepts we have learned so far about trigonometric functions in different quadrants. So let's apply that now. Now cos 2x can be written as sine of pi by 2 minus 2x, because cos x is nothing but sine of pi by 2 minus x. Similarly, sin 2x can be written as cos of pi by 2 minus 2x. Now let's apply that here. So the numerator would be cos 2x is nothing but sine of pi by 2 minus 2x, and in the denominator we would have 1 plus cos of pi by 2 minus 2x. Now to arrive at the values of pi by 4 minus x, we can rearrange this to sine of 2 times pi by 4 minus x, this whole thing divided by 1 plus cos of 2 times pi by 4 minus x. So this is of the format of sine 2x, where x is pi by 4 minus x, and cos 2x, which is pi by 4 minus x. Now let's apply the formula. 2 sine of pi by 4 minus x times cos of pi by 4 minus x, this whole thing divided by, now we need the answers in tan, so our denominator should have cosine in the higher degree. So that will be 1 plus 2 cos square pi by 4 minus x minus 1. So the 1 will get cancelled. So we would have 2 sine of pi by 4 minus x times cos of pi by 4 minus x, this whole thing divided by 2 cos square pi by 4 minus x. The 2 will get cancelled, one of the cosines will get cancelled, so this is nothing but tangent of pi by 4 minus x. So the concepts we applied is cos 2x can be rewritten as sine of pi by 2 minus 2x, sin 2x can be rewritten as cos of pi by 2 minus 2x, then just the application of the multiple and submultiple formula. So this is how we can solve the fifth question. In the sixth question, we have to prove that cos x divided by 1 plus sin x is equal to tan of pi by 4 minus x by 2. So we're going to apply the similar concept like we did in the fifth one. So let's try this out. So cos x can be written as sine of pi by 2 minus x. Similarly, sin x can be written as cos of pi by 2 minus x. So let's apply that here. So we would get sine of pi by 2 minus x divided by 1 plus cos of pi by 2 minus x. Now this can be further changed to sine of 2 times pi by 4 minus x by 2 divided by 1 plus cos of 2 times pi by 4 minus x by 2. Now we apply the formula of sine 2x where x is pi by 4 minus x by 2, and we apply the formula of cos 2x which has a similar angle. So but in the question we need the answer in the form of tan. So if it should be tan, we will have a higher degree of cosine in the denominator. So this will change to 2 times sine of pi by 4 minus x by 2 times cos of pi by 4 minus x by 2. This whole thing divided by 1 plus 2 cos square pi by 4 minus x by 2 minus 1. So minus 1 and minus 1 would get plus 1 and minus 1 would get cancelled. Then in the denominator, let's quickly solve this. We can actually cancel 2 and 1 of the cos. So this will change to tan of pi by 4 minus x by 2. So this is how we can solve the sixth question. Now I will also add the formula list that we had maintained in this video too, so that you can become familiar with all these applications. Thank you so much for watching till here. Please share this with your friends and also subscribe to the channel and give this video a like. And if you have any questions, please feel to drop a comment. I'll try to answer it as soon as possible. Thank you so much. Okay, here are the formulae that we learned up to this point. So I have listed down the formula we learned for trigonometric functions at 2x on the left side as well as at x by 2 on the right side. Please pause the video and make a note of these formula. Also try to memorize it. We are going to apply this formula in a lot of problems we are going to solve in the playlist. So please memorize it. Also maintain this formula sheet and go through these formula over and over again. So please pause the video and copy it. And thank you for watching till the end. I'll see you in the next video.